The following presentation was developed by John Avina, Director of Abraxas Energy Consulting. In a previous video, we discussed why we do weather normalization. In this presentation, we are going to learn how to do weather normalization, and we are going to explain it in a way which makes it possible to perform weather correction in Excel. You don't need fancy software to do weather normalization. However, specialized software does make it much easier. The first step in performing weather normalization is picking a base year. You need to pick a 12-month period before you installed your energy-efficient retrofits to use as your base year. This way, we have a whole year's worth of bill data to use for our weather normalization. Your base period could be 24 months. However, only 12 months of data is necessary and is actually more accurate in showing usage patterns. The second step in the process is determining how bills vary with weather. The graph displayed shows 12 electric bills. Each bill is designated by a blue dot. The graph shows usage per day versus temperature. The temperature is actually the average temperature in the billing period. We can see that as it gets hotter, more energy is used. The graph tells us that we are using energy to cool. In the next graph, we are able to see that energy is being used to heat and cool. The previous two graphs displayed usage for electrical meters. This graph displays usage per day versus temperature for a natural gas meter. Because usage increases as temperature decreases, we know that the natural gas for this meter is being used to heat the building. When we look at a graph like this one, we try to imagine two lines. One line is horizontal and the other slopes up to the left. The horizontal line represents non-temperature sensitive usage. This is the amount of energy used which has nothing to do with heating the building. This building is a hospital, so this type of usage could represent cooking, laundry, sterilizers, and domestic hot water usage. The pink region represents energy that is used to heat the building. The intersection of these two lines is known as the balance point, and the balance point is the temperature at which the building starts to heat. Now let's do another example with an electric meter which is used for cooling. Imagine two lines. The horizontal line represents non-temperature sensitive usage. This is a school, so non-temperature sensitive usage would represent usage from equipment like computers and lights. The line that slopes up to the right represents temperature sensitive usage. This is the pink region, and this represents the energy that is used to cool the building. Again, the balance point is where the two lines intersect. In this example, the balance point is the temperature at which the building starts to cool. So we found the balance points, but what do we do with them? We use the balance points to calculate degree days. Here we are calculating cooling degree days. For each day in the billing period, we take the difference between the average outside temperature, which is really the average of the high and low temperature for the day, and the balance point temperature. Remember, we just found the balance point temperature by looking at the usage per day versus temperature graph. We calculate cooling degree days for each day in our bill. To obtain the number of cooling degree days associated with the bill, we sum the cooling degree days for all of the days in our billing period. It should also be noted that you cannot have negative degree days. Let's say I have a balance point temperature of 65 degrees and an average temperature of 55 degrees. Cooling degree days would be 55 minus 65, which is negative 10, multiplied by 1 day. We cannot have negative 10 degree days. Instead, the number of cooling degree days for the day is 0. The process is the same for calculating heating degree days, except for one difference. Instead of calculating average outside temperature minus balance point temperature, heating degree days is balance point temperature minus average outside temperature times 1 day. We sum heating degree days for each day to get the total number of heating degree days in our billing period. Like cooling degree days, we cannot have negative heating degree days. Now that we know number of degree days, we can graph usage by degree days. In this graph, we have divided usage and degree days by number of days in the bill. We divide by number of days to normalize each bill. This allows us to put long and short bills on the same graph. The next step is to find the best fit line which represents our base year bills. This is the line that comes closest to all of the bills. Finding the best fit line is also known as regression analysis. Now we need to make sure the fit of our line is good enough. There are statistical indicators that tell you whether you have a good fit or not. The most commonly used statistical indicator is the R-squared value. If you are using weather correction or weather normalization for performance contracting, you may want to pay attention to the CV-RMSE and the mean bias. However, if you're an energy manager, the R-squared value is probably a good enough indicator of how well your best fit line matches your bill data. Now that you have established your fit line, what does it mean? Your fit line has an equation, and this is the baseline equation. You probably know that the equation for a line is y equals mx plus b. B is the y-intercept, and m represents the slope. This equation can be rephrased into something like this. The intercept is 2,872.7 times number of days, and the slope is 61.986. 2,872.7 times number of days is the non-temperature sensitive consumption. This would be the amount of energy used for lighting, computers, etc. The rest of the equation represents what is used for cooling the building. Some people's eyes start to glaze over when they see all this math. It should be noted that you don't have to do all this math. In this video, we are going over how to do weather normalization, because some of you are engineers or statisticians and need or want to know how weather normalization works. If you don't want to do all of this math, you can get software that will do this kind of analysis for you. Once you get the software, you enter the bills, enter weather data, do the regression analysis, which is actually very simple, and then you make reports. This report is one showing baseline and actual usage. Now let's briefly go back to the math. Remember, your fit line has an equation, which is called the baseline equation. The baseline equation represents the best fit line, and the best fit line is about the same as your base year bills. Now we can work with the baseline equation and we don't need the bills anymore. Remember, the baseline equation represents your energy usage patterns during your base year. So what good is the baseline equation? Well, we can take a current year bill, determine the number of days in the bill, determine the number of cooling degree days or heating degree days, and then plug these values into the baseline equation. So we have our baseline equation, we plug the numbers in, and we get baseline kilowatt hours. So baseline kilowatt hours represents how much energy your facility would have used in the current year given base year usage patterns in current weather conditions. The baseline equation represents base year usage patterns, and we applied current year weather to it to determine baseline kilowatt hours. So we have baseline usage, which represents how much energy we would have used. What you really want to know is savings. Did you save energy or not? To determine savings, you find the difference between how much you would have used and how much you did use. This is baseline minus actual. We calculated baseline already. Now we put our actual usage into our savings equation, and we can see we saved quite a bit of energy. Now let's do a quick review. We chose a base year, we graphed base year bills against weather, we found the best fit line, the best fit line represents the base year bills, the best fit line has an equation, the baseline equation, the baseline equation represents the best fit line, which represents the base year bills. We took a current year bill. We plugged cooling degree days and number of days from the current year bill into the baseline equation to get the baseline usage. Baseline usage is how much energy we would have used given base year energy usage patterns and current weather conditions. Savings is baseline minus actual usage, or how much we would have used minus how much we did use. I have just explained how weather normalization works. You can do weather normalization in Excel, but it can get tedious. If you only have a few meters, then Excel might be a good option for you. However, if you have several meters or don't want to get too involved in the underlying math, then you probably want to use software that specializes in weather normalization.